Hi, everyone. And today I'm very pleased to have with me Leo and Marius, the creators of this Symbolic AI, which is basically using symbols to represent information and performing operations on the symbols very flexibly. So I'd like to say hi to them. Would you like to just say hi, Leo and Marius?
Hi there.
Hi, everyone.
Yeah, so today is my privilege to just share with you how we could actually install and use this framework. So first up, if you look over here in this GitHub, which I'll link in the video, we first need to install Symbolic AI. So without further ado, let's go and do it. So the command is pip install Symbolic AI. And in order to get the latest version, we can use the -- upgrade command. So let's just run this. And after running, we have everything we need installed, and that's great. Okay, and what's next? Okay, what's next is you need to run this in your terminal, export OpenAI API key, and then you have this API key here to put inside this, and you do this also in the terminal or in the command prompt. All right, and to do this, you just go to your OpenAI API. Okay, you go to your keys, API keys, create a new secret key. All right, and then you copy and paste the key. I'm not going to show this here, but this is how we do this. All right, so again, going back to the OpenAI page, I'm using it at 49 cents. I just want to show you, like, if we use ChatGPT on this framework, how much it will cost. Okay, it won't cost much. All right, so after we have installed, let's go to one of the notebooks. Again, I also link this notebook in the video as well. So what we will first do is everything is inside this Sim AI package. All right, so we'll import stuff with the Sim AI package. Let's just run this. Okay, the default is actually still GPT-3. So if you want to use like a cheaper API, so you can use the GPT 3.5 Turbo. So you can do this in your engine. Okay, again, this is only the neural symbolic engine, which is like how you use language models to interpret the operations flexibly. Actually, their framework does a lot more. There's also the OCR engine, speech to text, Wolfram-Alpha, which you can then also use like your own API keys over here, all right, which I won't show today. But you can do this as well if you want more stuff. They even have Pinecone. See, there's a lot of interfacing here. So it's actually very, very powerful if you can use all these engines all at the same time. So let's just set up and first describe what's a symbol. Okay, so you all might be wondering what's a symbol. Okay, let me just expand this view so that you can see this more. Let's go to Zoom. Yeah. So can you see the screen? Yeah, just
Yes, great.
Okay, so a symbol is basically a way to store information, and this information could be in the form of text, it could be in the form of numbers, even NumPy arrays can be a symbol, mathematical operations can be a symbol. So let us just put hi there as a symbol, and we can see that this hi there, once you print the symbol, the text comes out. Okay, we can even do addition like that. And if you add like maybe a string of text like how are you, this how are you will be dynamically converted to a symbol as well. So this is the symbol-based class, and you can see we can also print out the symbol value using sim.value. Okay, you might be asking, why do we need to use symbols, right? Because actually, if you use symbols, there's a lot of pre-built functions that come along with it that enable you to do very, very versatile operations. So one of the operations is like this translate. Okay, so whatever you have in this symbol, it could be numbers, it could be text. Okay, as long as you can represent it in a string, it can be a symbol. So this symbol is really the backbone of this whole architecture. You manipulate symbols using operations. And one of these operations is the translate operation. And you can even specify what language you want. So this is translate to German, and you get this. Okay, of course, you can translate to other stuff like French. You can get another text. Yeah, so this is very, very flexible. You can imagine doing this in the ChatGPT API as well, but you can do this natively in the symbol API. So that's great. You can also do sentiment analysis by doing like this. Like, for example, this hi there, how are you? What kind of sentiment is it? Is it angry, neutral, hate speech, happy, or unknown? All right. And if it cannot classify it, if the large language model doesn't know what the answer is, it will be unknown. So let's run this. So sim.choice is a way to do classification, and indeed is neutral. All right. So it could also be happy or neutral. So a lot of these operations, okay, and Leo and Marius would also explain later. A lot of this at the back end, they are using prompts to the large language model in order to process the data in the most user-friendly way for you. Okay, so what you can see here, you can see the output here, but behind the scenes, there's actually prompts. right? So if we have time later, we can also go through some of the prompts used. So another thing you can do for symbols is you can do something like mathematical operations like this, x plus 1. And you can use this thing called expression. Okay, expression enables you to perform additional operations on the symbol that is not really pre-planned in one of these operations. So you can actually write your own operations using text. That's really cool, right? So like one of the operations you can do is to like describe the symbol. So you can see this represents adding 1 to an unknown value of x. You can even do some interesting stuff to it. You can like say, as long as you have the word self in expression, all right, you can do something related to self. So like self plus 3. So that will be x plus 4. You can even do stuff like self times self. Okay, what do you think will come out? X squared plus 2x plus 1. Interesting. So you can do stuff like this just by using the word self, and this will manipulate the symbol directly using this expression. Okay, and this is something that is really, really cool. You know, the vector embeddings, like king minus man plus woman gives you queen, because you know, remove the man from the king and you add woman, you get a female king, which is like queen. You can also do the same thing using expressions. So over here, the expression is actually the same as doing expression self. All right, and then you can get queen. So this will evaluate whatever is in this text, which in this case is a minus and a plus operation, to the best effort of the large language model. So you can do it without expression as well. So, okay, see, now we get princess. Okay, this is some stochasticity, but overall, this is the best effort evaluation of the model. So expression is a way to make symbols more versatile by letting you define the kind of operations you want on the symbols itself. All right, and what other nice functions that we have? We have this thing called compose. Okay, so if you are in the mood for getting very long text, descriptive text, or creative text, you can do compose, and they will compose based on the prompt over here. So if I want to have a poem about large language models, okay, for the fun of it, let's just generate this, and we can see what happens is the large language model will give back, oh, in the world of natural language processing, a new breed of models have emerged to make processing less distressing and so on. So we can even ask it like, you can do question answer on this text using the query method on the symbol. So this query method will ask, what is the key point? Or you can ask any question you want, like who is the main character, or like what is the meaning of natural language processing? Okay, maybe let's just ask like, what is the meaning of natural language processing? Or let's come up with something like what can what can large language models do? Because that will be based on the text here, right? What can large language models do? Let's take a look. Understand human language, analyze it on massive scale. So you can see, okay, and then they can be trained on any size of data on any size, such as answering emails and so on, and composing text. Yeah, so this shows that it can do question answer using the query key, which is really cool because you have just earned yourself a question answer machine just like this using the symbol architecture. And that's not all. So about 2 weeks ago, I met with Leo and Marius, and I asked them, can you perform the Wolfram-Alpha's, let me just show you this, Wolfram-Alpha LLM-based functions. So this is like how it looks like in Wolfram-Alpha. You can write your own functions there, all right? Something like this, write in active voice, and then you can put in the input to the function, and then the output will be right in active voice. And you can also put some examples here. So I asked them, can we do this also in your Symbolic AI framework? So I don't have to download Wolfram-Alpha. Yeah. So they just basically coded this in like 5 minutes. So right, if I'm not wrong, Marius, you took about 5 minutes, right, to code this. All right, so let's take a look.
It was very easy, yes. Thank you.
Yeah, so it was already inbuilt in the function. It's in the few short wrapper function. They just modified a bit and it became an LLM function in Wolfram-Alpha. So let's take a look at how it's done. So you can just specify what you want to do in the function here, like convert to active voice. Then you take this function, you can run yourself, like there was man running along the road. And by doing the large language model, this will convert to something like this. A man was running along the road. So this is exactly what this function is doing. We can even do like few short examples like this, evaluate this category odd or even. All right. And then you need to specify, provide the answer exactly, because large language models, they sometimes don't give you the exact answer. But you can give it like some examples like 1 is odd, 4 is even, like that. All right, and then you can just like do like odd, even, 9 is 10, odd 9 is odd, 10 is even. So this is already done. So a few short example prompting is there also, right? So we can even do something like a poem generator. Like, for example, you can just write a poem of input, right? And what we can do is we can chain the functions together. So each of these functions are dynamically specified by your prompts. Okay, no longer do you need to type in the exact code. You can just type this whole thing in text, and then this can be evaluated using the large language model to get your function. So let's see. This one is, you see, now we do odd, even, 9. This will be odd, and then we generate a poem about odd. So in the realm of numbers and odd entity exists and so on. So this is really how you can chain functions together. Okay, we can do it like our own functions. You name it, you can just do your own one. Like for example, if I want to do another function, like I want to count the number. Okay, let's see, count the number of x in the input. Yeah, so we can do another function like that. And then what we can do is we can just do like this, x, x, xy, xy. Okay, I'm not really sure whether this can work because large language models tend to have character issues. Let's just take a look, x, y, x. So you need to do something like this. Yeah, so this is one of the limitations of GPT, not on this function. So you can see if you label it like this, you can do an arbitrary function just like that. Okay, so this is just one of the ways you can do your own function. You name it, you can type it yourself here, and this can be used in your code. Next time you can just run this function and you can get the output. Okay, again, if you want to constrain your output here, just here they put 3 occurrence. Okay, give the answer only as a single number without explanation. You can just put something like that, and you can see the answer is 3. All right, so this is how we will do the large language models function. So,
and also maybe to add on this, with better models like GPT4 and so on, the better the expressions and the processing is, but obviously more costly.
Yeah. So regarding cost, let's just take a look. So the cost is, just now was 49 cents. Just take a look after I ran like about 20 over prompts. Okay, I only use 1 cent. All right, so it's really very cheap. And this is something that is really cool. And if you want to try it out yourself, just go to Symbolic AI, the GitHub. Okay, do the steps that I did earlier, which is pip install Symbolic AI. If you want the latest version, you should do -- upgrade. All right. And then from there, you can just, based on this example notebook, can play around with the functions. Okay, they even have other stuff like streaming of web tags, web crawlers, and so on. You can take a look at some of the example notebooks on this over here, like the news generation and so on. So today I only show you the basics notebook. So yeah, actually that's more or less all for the live demo. Marius and Leo, you have anything else you want to tell the viewers about?
Yeah, maybe also if you're like a bit of a script kiddie or like some working the shell and so on, we have also some shell tools already provided. So you basically could directly get like any kind of PowerShell, or it's basically prompt in the background that kind of curates the model to already provide things like that. Or you could directly chat with our Symbia, which is our own so to say chatbot implementation, and all of these things. You can just check it out in the description of the entire repo.
Yeah, if not, actually this is like more or less the code over here. Maybe we can take a look at some of the prompts backend at how like this works. So all this is fully open source. So let's go to prompts.py. If I'm not wrong, this is where the prompts are, right?
Exactly.
So we have stuff like fuzzy equals, like you can evaluate symbols to see whether or not like 6.0 is the same as 6, So this is all done using large language models, few shot learning, right? Let's see what other prompts we have. Can we go and take a look at the compose one? Is it here?
Yeah, just look for compose.
Yeah, let's see how we generate the, oops, okay. Let's see. Okay, I can't really, maybe I typed wrongly.
Wait, let me just check. So compare.
You can see these are all the kind of like few shot learning instances that's all in the prompt itself. So yeah, it's pretty cool. Like at the back end, it's actually just going through the language models to do all this kind of stuff for you. Yeah. So yeah, Marius, Do you know where
Yes.
the compose is? Yeah,
The
just want to-
compose is not in here because it's it's a zero shot. But
Alright.
if you take something else like combined text or something what you have right now, then you will find other things like what did you show also the query, I think was or not the query, what was it? Yeah, anyhow, these are more the formatted things if you want. So if you want have a specific structure that you want to extract, then you find usually the prompts here, because the other ones you can find in the core.py.
Yeah, I think the rest are in symbols. So like a symbol, you can see this is the base symbol class for those interested. So there's a
Yeah.
value for a symbol, there's a global context and a static context and a dynamic context here. All this not really needed to know for you, but this is basically how a symbol like gets manipulated. They actually do this kind of operations on each other. Yeah, so this is basically where all the magic happens. So yeah.
Here you can look for the compose, for instance, and then you will see that this is kind of using we use everything based on decorators, and all the decorators can be found in the core, basically core.py, and there you will find a lot of like compose, for instance, and a lot of few shot examples already how we use those things.
Yeah, so this is the way we generate the poem just now. Create a coherent text based on the facts listed on the outline. Yeah, and you can see all of this actually linked back to this few shot function. Most of the core functions that you see in the symbol are all linked to this few shot, and this few shot is in functional, if I'm not wrong.
So yeah, implementation is in functional then.
Yeah, so this is how the few shot function is, and you can see that there's a lot of stuff, and all this basically goes through a language model to process it. So the structure based on how I talked to Marius and Leo the last time, all these are heavily influenced by the PyTorch architecture, whereby we have basic functions, and then the more abstract functions will call on these basic functions and build on that. So what you can see is we have a symbol class, and in the symbol class, we have different functions that are all powered eventually by some large language model in this functionals class using the few shot function. And for other engines, you also get powered by other functions. Like for example, the OCR engine and the Wolfram-Alpha engine will all be powered by different functions. All right. Yeah, I think this is a low level enough view. If you're interested, please feel free to go through the documents yourself. And but the main thing is you can just use it like that. Yeah, you can just use it as a symbol. You can manipulate the symbols and you can do wonderful stuff with it. If it's not enough, you can use expressions. And if that's not enough for you, you can even do your own functions using the LLM functions. All right. So yeah, maybe some concluding note. Leo or Marius, you have anything else to add before we end today?
So yeah,
from
go ahead. Sorry.
Yeah, Leo, go ahead.
Sorry. From my side is one very important note. So capabilities between GPT-4 and ChatGPT cannot be stated. So it's very difficult to solve some tasks with ChatGPT. So this is very important to be kept in mind, especially for the chatbot, for example, because the chatbot has very difficult promptings behind when we should do in context classification. And if in one case, if there is something going wrong there because the in context was not properly done by ChatGPT, then you can expect like super weird behavior. So to me, at least from a developer perspective, I was super surprised when I've seen how good the in-context classification or in-context learning is with GPT-4. Extremely good. So just only this as a short note for
anyone.
So
to set the expectations, I think that's what Leo wants to say. So if you want the more complex expressions, the more complex evaluations and so on, to keep in mind that obviously older or smaller models might not be enough. So you have to like upgrade or set the corresponding models properly. What else we could also add on, because I like what you said, you mentioned the PyTorch similarities, because that's exactly one of the things that we kind of follow from the design principles, that we also can streamline between different expressions. So you can define your, if you want, so functions and expressions that you can manipulate stuff, and then basically create a sequence of these expressions, execute all of that in a sequence, and maybe even process a large document by like streaming through all expressions. So basically you have this kind of sequential processing of different chunks of your text, for instance, and then you could combine those chunks again, which I can also showcase quickly if you just want to see a short demo afterwards.
Yeah, it's all right. We can have another session with you all to showcase more advanced functionalities. But for today, I think this is what you all can play around with first. And we definitely can see, like, there's also this chatbot called SimChat, which is really cool. We can see that next time. All right. If not, let's just end for today. Thanks for your time, Marius and Leo. And we'll see you all again soon.
Thank you.
Bye.
Thank you.